हेलो फ्रेंड्स, वेलकम यू ऑल हियर। यदि आपने अब तक हमारे यूट्यूब चैनल को सब्सक्राइब नहीं किया है तो अभी दबाएं सब्सक्राइब बटन को। इसके बगल में दिए गए बेल आइकन को दबाना न भूलें ताकि हमारे सारे नए वीडियोस आपको सबसे पहले देखने को मिलें। धन्यवाद।
हेलो स्टूडेंट्स, जैसा कि आप जान रहे हैं इस लॉकडाउन में हमारे बच्चों का पढ़ाई का बहुत ही नुकसान हो रहा है। तो एक छोटी सी पहल है कि मैं इसके वीडियोस बना करके अपने पढ़ने वाले बच्चों के लिए मैं कुछ भेज सकूं। तो मैंने आज क्लास 9 का मैथमेटिक्स पहला चैप्टर मैंने सेलेक्ट किया है और वो पहला चैप्टर है नंबर सिस्टम्स। सवाल उठता है कि नंबर सिस्टम की ज़रूरत क्या है हमारे जीवन में। तो सबसे पहली बात है कि हमारी डेली लाइफ में हर जगह नंबर सिस्टम की ज़रूरत पड़ती है। मैथमेटिक्स हमारी डेली लाइफ में यूज हो रही है। हम देख रहे हैं कि कंप्यूटर का युग है। हमारे कंप्यूटर में भी जो उसकी लैंग्वेज है वो इन्हीं नंबर पर बेस्ड है, नंबर सिस्टम पे बेस्ड है। और हम देख रहे हैं कि इनका दिनों दिन यूज़ बढ़ता चला जा रहा है। तो सबसे पहली बात आती है कि नंबर सिस्टम की शुरुआत कहाँ से हुई। तो मैं आपको बताना चाहता हूँ कि बिगनिंग ऑफ द नंबर सिस्टम इज वेरी ओल्ड एज हिस्ट्री ऑफ सिविलाइजेशन। जितना हमारा सभ्यता का विकास हुआ, जब से ह्यूमन ग्रुप में रहने लगे और सभ्यता का विकास हुआ, तभी से नंबर सिस्टम की ज़रूरत पड़ी। जब पीपल ग्रुप में रहने लग गए तो उनको गिनने की ज़रूरत पड़ी, काउंटिंग की ज़रूरत। दे आर काउंटिंग देयर एनिमल्स, पेट एनिमल्स, एंड पीपल्स इन द ग्रुप दे आर आल्सो काउंटिंग द नंबर ऑफ पीपल इन द विलेज एंड सो ऑन और इन द ग्रुप। So very first number system is natural numbers. So natural numbers are also called as countings. So such numbers which are used for counting the objects, such type of numbers which are used for counting the objects. For example, one chair, one pen, two table, five people. So you can see it is a need to represent by someone. You can see ONE1, 2, 3. They are and 4. These numbers are represented by different symbols in different places, in different countries. But one number system is international number system. In international number system, you can see the representation of these numbers like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So these are the natural numbers or counting numbers. Smallest natural number is 1. Every natural number has its successor. Successor means just after next natural number. So successor of 1 is 2, successor of 2 is 3, successor of 3 is 4. Now same thing is predecessor. Predecessor means just before, means predecessor of 4 is 3 and predecessor of 3 is 2. Predecessor of 2 is 1. 1 has no predecessor in natural numbers. Is it clear? Now you can see smallest natural number is 1. Now come to the next number system. You can see when you are subtracting any number by same number, you can get another number that is called 0. 0 is not in natural numbers. It means there is need of extension of number system. इस नंबर सिस्टम को आगे बढ़ाने की ज़रूरत क्यों पड़ी? क्योंकि जब हम किसी एक नंबर में उसी नंबर को हम माइनस करते हैं तो यहाँ पर जो मिलता है नथिंग. सपोज यू हैव 5 रुपीज नोट एंड यू हैव गिवन टू समवन एल्स. हाउ मच नोट यू हैव? सो दैट इज नथिंग. फॉर नथिंग means 0, symbol is 0 for nothing and it is not present in the natural number. So there is need of extension of the number system. So such numbers are called whole numbers. So whole numbers means all the natural numbers included 0. What are these? All natural numbers and 0 together form whole numbers. So you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Natural numbers in mathematically represented by capital N. Mathematically set of natural number is denoted by N and all the whole numbers are denoted by letter W. W stand for whole, N stand for natural. So this is the number system. So you can see here what problem. Suppose 1 is added with 2. So you can get the sum as 3. 3 is also whole number. But if a smaller number, suppose 2 is there and 2 is subtracted with 1, so your answer is coming 1. So 1 is also whole number. But if you are subtracting 5, you are subtracting 7 from 5, you will get another type of number. You can see such numbers are negative. You can see this is not part of whole number. So it means there is need of extension. Need of extension of whole number. So new number system generated. These numbers are called integers. You can see integers. So integers define, how you will define the integers? All the natural numbers, their negative numbers and 0 form integers. Learners, types of integers, you can see there are three types of integers. There are three types of integers. Number first, positive integers. Positive integers, you can see 1, 2, 3, 4, 5, 6, 7, etc. and so on. These are called positive integers. Positive integers are also called as countings. Countings, or you can say natural numbers. Natural numbers. Is it clear for all? You can see positive integers are all the counting numbers, and these are also called as natural numbers. Now they are represented by some symbol, either I plus, first type, I plus, or one more letter is there, Z plus, Z for integer or I. Anything you can, either you can, generally we are representing by I plus. Second one is negative integers. Negative integers, you can see negative of whole numbers. These are represented by I minus, or minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and so on. And third type of integer is 0. 0 integer. You can see positive integers, negative integers, and 0 integers has only one number, that is 0. 0 integer has only one number, that is 0. Now come to see smallest positive integer. Smallest positive integer is 1. Largest negative integer is minus 1. And you can see 0. 0 is neither positive nor negative. It is itself a integer. तो हमने देखा नेचुरल नंबर्स, होल नंबर्स, इंटीजर्स, एंड इंटीजर के थ्री टाइप्स देखे हमने, पॉजिटिव इंटीजर, नेगेटिव इंटीजर एंड जीरो इंटीजर. Now you can see also need of the extension of the number system. You can see the extended form of this number system known as rational numbers. Why there is need of rational numbers? Suppose students, you are dividing 15 by 5, so your answer is coming 3. But what will happen when you are dividing 5 by 15? You can see, you just simplify, you can get 5 1 is 5, 5 3 is 15, so 1 upon 3. You can see such types of numbers not lying in the integers. It means need of extension of the number system. You can see, so such type of number systems. So see about the rational numbers. Any number of the form P upon Q, where P and Q are integers and Q should not be equal to 0 integer. So any number of the form P upon Q, it is already written, or you may write both way. You can see this, for example, I would like to explain. Suppose 22 upon 7. You can see 22 upon 7 is in the form of P upon Q. Here Q is not equal to 0. So this number is rational number. Suppose one number is there 1.5. So you can see this number is not written in the form of P upon Q, but you may write. You can convert it into fraction by multiplying it by 10, numerator and denominator. So you can write 15 upon 10, and if you are simplifying by 5, 5 2s are 5 3s are. So your answer is coming 3 upon 2. Now you can see 1.5 can be expressed in the form of P upon Q, means 3 upon 2. It means this number is also a rational number. Now see some more types of rational numbers. You can, one definition is this. See second one. All the terminating decimals. All the terminating decimals are rational numbers. Rational numbers. So for example, you can see 4.53. This number terminates after two places of decimal, 15.3 and 71.1349. You can see this number terminate after 4 places of decimal. So these are the terminating decimal numbers. All these terminating decimals are rational numbers. तो आपने देखा कि रैशनल नंबर्स, पहले कोई भी नंबर p अपॉन q के फॉर्म में लिखी हो और p and q are integers and q is not equal to 0, then that number is rational number. Second type you had seen that any number which is terminating decimal is called rational number. Now see the third type. Any non-terminating repeating any non-terminating repeating decimal are rational numbers. For example, you can see one number, suppose 7 upon 3 is given. If you are going to divide This 7 upon 3, if you are dividing, you will get 2.333. Never stop. The value of 7 upon 3 is 2.3333 and so on. You can see such numbers are also called as recurring decimals. Recurring decimals, or one more name is periodic number. Periodic numbers. Such numbers, you can see some more examples. 71.123 dot. This dot is representing that this number never stops, it never terminates. So it is very difficult to write in this way. Same number you can write it as 71.123. How much digits are repeating? You make bar above it. You can see 1, 2, 3, 3 numbers are repeating. So you use this bar. The meaning of this one is given this extension form. So this is the third type of number, which is rational, non-terminating, repeating decimal. These are also called as recurring decimal or periodic numbers. Okay. After rational numbers, there is need of extension of the number system. You can see irrational numbers. So irrational number, generally we are saying a number which is not rational. A number which is not rational is called irrational number. This is general definition. So you can see a number which is not rational is called irrational number. One more definition you can see: non-terminating. Non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals are called irrational numbers. For example, I would like to explain 7.2022202220 and so on, never terminating. This is example of non-terminating, non-repeating decimal. You can see such type of numbers: √2, √3, √5, √7, √8, √10, etc. These numbers are also, you can see, these numbers are all irrational numbers. Come to see One more thing, one indication, pi is also irrational number. Irrational number pi. You can see the irrational number pi. So in detail I would like to explain about the irrational number pi. You can see natural numbers, whole numbers, integers, rational number and irrational numbers. नंबर सिस्टम को हम अब सिंबॉलिकली आपको समझाने की कोशिश करेंगे। जैसे कि स्टार्टिंग हमने कहाँ से किया था, वो था नेचुरल नंबर। यू कैन सी नेचुरल नंबर्स। नेचुरल नंबर्स आर डिनोटेड बाय लेटर एन। एग्जाम्पल 1 2 3 4, so many 5. You can see these numbers are natural numbers 1 2 3 4 5 100 200 300 and so on. If we are using including 10, you can see if 0 is added here, you will get whole numbers, set of whole numbers. It means all the natural numbers are whole numbers, but all the whole numbers are not natural number. 0 is not a natural number. All the natural numbers are whole number. Now see, if we are considering here -1, -2, -3 and so on, -4, -5, -6, -7. So number system converted into the set of integers. This one is, you can see these are the integers. If these integers including such type of numbers 1.5, 22/7, 11/12 and 1.234 repeating, such type of numbers, you can see all included, they are called rational numbers. So this square diagram is representing set of, suppose rational numbers are represented by Q. So Q stand for set of rational numbers. So you can see all the natural numbers are rational numbers, all the whole numbers are rational numbers, all the integers are rational numbers. Now you can see any number which is not a rational number is called irrational number. Suppose √2, √3, 1.30330 ... pi. One more number e is also a irrational number. You will study further in higher classes. So if both including, it is denoted by q dash, symbol for the irrational number. irrational number का symbol होता है q dash. If we include rational number and irrational number all together, you can see another type of set of real numbers. So students, you can see all these q indication for the rational numbers. All this box, which number is lying in the box, these are rational, and below one box is there. Here you can see all these numbers are irrational. So you can see combination of all the rational numbers as well as irrational numbers together form the set of real numbers. New type of number, real numbers. So I would like to tell you about the Real numbers is nothing. You can see combination of rational and irrational numbers. With the help of one diagram, you can see concept of the real numbers. Suppose there is a tub and we are pouring a jug. It is filled with all here rational numbers. So many numbers poured in this tub. These numbers are falling from there. These are the rational numbers. And one more jug is here. Again it is poured. Here you can see irrational numbers are in this jug. Means root 2, root 5, root 7 and so many numbers all together mixed. So 1.50550 dot. Here pi is also, E is also 1.5, 7.3. All numbers here from the both container. You can see rational numbers as well as irrational numbers. When together we are mixing, this is known as set of the real numbers. So concept of real numbers is clear for all. You can see combination of the rational and irrational both numbers is called real numbers. So I think concept of real number is very clear. In real numbers, you can see all the rational numbers are real numbers, all the irrational numbers are real numbers. So students, you can see concept you can make in your mind. All the natural numbers are whole number, all the whole numbers natural numbers, all the whole numbers are integer, all the integers are rational numbers, and all the rational number and irrational together forming the set of real numbers. Definition of pi. You can see students the definition of pi. Very first time our great Indian mathematician Aryabhatta has given the concept of pi. You can see, suppose circumference of this circle is denoted by C and its diameter is denoted by D. Its diameter is denoted by D. So circumference divided by D for any circle, this ratio remains constant. So you can see ratio of circumference to diameter of any circle is constant for each and every circle. Beyond its diameter is how much. You can take any radius to draw the circle. For each and every circle, the ratio of circumference and diameter remains constant, and this constant is denoted by pi. It is given very first time by great Indian mathematician Aryabhatta. This is the definition of the pi. So irrational value of the pi is, you can see already I have written here on the board. पहले से हमने यहाँ लिख रखा है कुछ places तक. The value of pi is never terminating, never repeating. That's why we are saying irrational number pi. Million, billion, trillion places of decimal it was discovered, and so many mathematicians work on it. One more great Indian mathematician, Srinivas Ramanujan, also obtained the value of this into million places of decimal, but he was found that the number is neither terminating nor repeating. So whole world mathematicians are following that this number is not rational, it is irrational number. So students, we are using every time when we are doing the problem of mensuration. Suppose we want to get the area of circle, we are applying pi r square. So the value of pi, sometimes we are putting its rational value. Approximate rational value of pi is 22 upon 7. Actual, this value is not real value of pi, but somewhere we are considering very close rational value 22 upon 7, and you can see one irrational value. Irrational value of the pi we can using up to 2 places of decimal 3.14. We are considering this is non-terminating, non-repeating, so we are taking up to 2 places of decimal. We can see this is irrational value of the pi, but we are taking, when we are calculating, we are taking only 2 places or 3 places of decimal. So students, you can see pi is an irrational number, but its rational close value is 22 upon 7, and sometimes we are writing in decimal place 3.14. So students, this is the concept of irrational number pi.